Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the formal charge. In the previous lecture, we have learned how to draw the Lewis structure using the Lewis symbols of the different atoms and following the octet rule. Today we are going to find the formal charges using the Lewis structure. What is formal charge? Formal charge is the actual electrical charge possessed by an atom in a covalent compound. Let me write this thing for you. Formal charge is actual electrical charge of an atom in a covalent compound. Now, we will follow the formula to evaluate the formal charge. The formula for evaluating the formal charge is equal to the number of valence electrons in an atom minus number of non-bonded electrons of that atom minus number of bonds formed by that atom in a covalent compound. So what is formal charge? The number of valence electron in an atom minus number of non-bonded electrons of that atom in a covalent compound. Let me write this thing complete. In a covalent compound. Minus the number of bonds formed by that atoms in a covalent compound. Now, let me take an example. Firstly, I am taking an example of alcohol. Its example is CH3OH. Let's make its Lewis structure first. Carbon has 4 valence electron. 1, 2, 3, 4. Oxygen has 6 valence electrons. Oxygen has 6 valence electrons, so it's first, second, third, fourth, fifth, sixth. Now let's talk about the hydrogen. Hydrogen has 1 valence electron, another hydrogen 1 valence electron, next hydrogen 1 valence electron, and one more hydrogen with 1 valence electron. Now these are the covalent bonds formed between the atoms in case of CH3OH, in which the octet of carbon and the octet of oxygen is completed and the duplet of hydrogen is completed. So now we are going to evaluate the formal charge on carbon and the formal charge on oxygen. Let's come to the formal charge of carbon. What's the formula? Number of valence electrons of carbon, that's 4, minus number of non-bonded electrons in carbon in a covalent compound. Just examine the CH3OH. In CH3OH, let's talk about the carbon. In carbon, we are not having any non-bonded electrons in case of carbon. So here, non-bonded electrons are 0. After that, minus the number of bonds that have been found by carbon in a covalent compound. So here, the number of bonds formed by carbon are 1, 2, 3, 4. The carbon has formed 4 covalent bonds in the CH3OH, so it comes out to be 4 and it comes out to be 0. That means carbon is neutral in case of CH3OH. Now, let's talk about the formal charge on oxygen atom. Now, what's the valence electrons of oxygen? It's 6 minus the number of non-bonded electrons of oxygen in CH3OH. Let me count it for you. The non-bonded electrons are number 1, number 2, number 3 and the number 4. These 4 are non-bonded, so it comes out to be 6 minus 4. After that, number of bonds formed by oxygen in CH3OH. The number of bonds are 1 and 2. So here we are going to minus 2 over here. So it comes out to be again 0. That means oxygen is also neutral in case of, oxygen is also neutral in CH3OH. So that's my first example. Now let's come to the another example, and I'm taking it to be ozone. I'm taking an example of O3. Let's first understand the Lewis structure of ozone. It's a bit different. Sorry. That's my oxygen number 1. That's my oxygen number 2. And that's my oxygen number 3. How many valence electrons does oxygen have? It's 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, what's gonna happen? The first oxygen is going to share its 2 electrons with the second oxygen. So that's the first bond. Here it comes to be the second bond. And now you can examine that octet of both the oxygens, that's oxygen number 1 and 2, is completed. Let me count it for you. That's electron number 1, 2, 3, 4, 5, 6, 7 and the 8. So the first oxygen got 8 electrons in its outermost shell after the formation of 2 covalent bonds. That means the octet of first oxygen is completed. Now let's talk about the second oxygen. Is 1, 2, 3, 4, 5, 6, 7 and the 8. So the octet of second oxygen is also completed. Now the question arises, then why do any of these oxygen will form bonds with the third oxygen? Here's the question. So to form the bond between the oxygen number 1 or the 3 or 2 or the 3, there will be one technique, and that's called coordinate bond, which we will going to be discuss in our next lectures. Let me do this thing for you first. What's gonna happen? Actually, let this oxygen number 2 gives its 1 electron to the oxygen number 3. Okay, now then what will happen? This electron has gone over here. Now after that, count the valence electrons of oxygen number 2 and 3 after this process. As I'm counting the electrons of the oxygen number 2, That's number 1, 2, 3, 4, 5, 6 and the 7. Right now oxygen number 2 is having 7 electrons in its outermost shell. Now let's talk about the oxygen number 3. That's our first electron, the second electron, the third electron, fourth electron, fifth electron, sixth electron and the seventh electron. It's also having 7 electrons in its outermost shell. Now, what's next gonna happen? Now, oxygen number 2 will share 1 electron with oxygen number 3, and then the octet of both of the oxygens will get completed. Let me show this for you. That's the covalent bond like this. Now let's again count the electrons of oxygen number 2 and 3. Now it's number 1, 2, 3, 4, 5, 6, 7 and the 8. So that means oxygen number 2 got 8 electrons in its outermost shell. Now let's count the total electrons of third oxygen. Now it's number 1, number 2, number 3, number 4, number 5, number 6, number 7 and the number 8. So the octet of third oxygen also gets completed. I'm recounting the electrons of oxygen number 2. I'm recounting the electrons of oxygen number 2. Sorry. It's number 1, number 2, number 3, number 4, number 5, number 6, number 7 and finally the number 8. So the octet of oxygen number 2 is also completed. Octet of oxygen number 3 is also completed. Now focus on the bond which I have shown with the green color. The bond which have been shown by green color, you can easily observe that both the electrons of the green color bond are of oxygen number 2. This type of bond in which the shared pair of electrons are contributed by only one atom, that's oxygen number 2. Here both the electrons of the green bond is contributed by the oxygen number 2. This type of bond is called coordinate bond. Coordinate bond. Now, as the oxygen number 2 has donated its electron to the oxygen number 3, due to which oxygen number 2 will carry a +1 charge, and oxygen number 3 has gained an electron from the oxygen number 2, so oxygen number 3 will have a 1 negative charge. Now let's evaluate these charges by the formula of the formal charge. Now, formal charge on oxygen number 1. I'm talking about the oxygen number 1 first. How many valence electrons does oxygen have? It's 6, minus the number of non-bonded electrons in oxygen number 1 are the number 1, number 2, number 3, number 4. These 4 electrons are in non-bonded state, so it comes out to be -4. Then the number of bonds that have been found by the oxygen number 1. So the number of bonds are it's the number first bond, the second bond. So we are going to -2 over here, and this thing comes out to be 0. That means oxygen number 1 has a 0 formal charge. That is, oxygen number first is neutral. Now let's talk about the formal charge on oxygen number 2. Formal charge on oxygen 2. How many valence electrons does oxygen have? It's 6, minus number of non-bonded electrons. Now let's count the non-bonded electrons for the oxygen number 2. That's number 1 and the number 2. There are only 2 non-bonded electrons. It comes out to be 6 minus 2. After that, the number of bonds formed by oxygen number 2. So let's let's count the number of bonds formed by oxygen number 2, and these are the first bond, the second bond, and the third bond. The oxygen number 2 is forming 3 bonds, so it comes out to be -3. Now 6 minus 2 minus 3 comes out to be +1. That means oxygen number 2 will carry a +1 charge. So now let's evaluate the formal charge on the oxygen number 3. Formal charge on oxygen number 3. Now the number of valence electron in oxygen is always it's 6 minus the number of non-bonded electrons. Now I am counting the non-bonded electrons for oxygen number 3. That's number 1, number 2, number 3, number 4, number 5, and the number 6. So it got to be 6. Now it's -6 minus the number of bonds formed by oxygen number 3. Now the number of bonds formed by oxygen number 3 is only 1, and the bond is this. So it comes out to be 1. So it comes out to be -1. So that means oxygen number 3 is having -1 charge. So we got the formal charges. In case of ozone, that's O3. The formal charge of oxygen number 1 is 0. For oxygen number 2 is +1. And for oxygen number 3 is -1. Now let's take the another example. The third example I'm taking it to be carbon monoxide gas, CO, the carbon monoxide. Now, how many valence electrons does carbon have? It's 4. 1, 2, 3, and the 4. How many valence electrons does oxygen have? It's 6. Oxygen 1, 2, 3, 4, 5, and 6. Now let's make the bonds. I'm focusing right now firstly oxygen, the very first bond, the very second bond. Now here the octet of oxygen is completed. How? Because oxygen will form only 2 bonds to attain the octet, but carbon needs 4 covalent bonds to attain the octet. Now let's count the electrons. That's number 1, number 2, number 3, number 4, number 5, number 6, number 7, and the number 8. So we got the 8 electrons in the outermost shell of the oxygen. Now let's count the electrons for the carbon after the formation of 2 bonds. That's number 1, number 2, number 3, number 4, number 5, and the number 6. So oxygen got only 6 electrons, whereas oxygen has attained the octet of 8 electrons. So what next can happen? For this thing, oxygen will make a favor to carbon by gifting or donating its 1 electron to the carbon. After that, what's gonna happen? Now this electron has been donated to the carbon, so we got 1 electron over here. Now let's recount the number of valence electron for both the atoms, the carbon and the oxygen. Now I'm counting for carbon. Number 1 electron, number 2, number 3, number 4, number 5, number 6, and the number 7. Now the carbon got 7 electrons in its outermost shell. Now let's count the valence electrons for oxygen after the formation of 2 bonds and after the donation of 1 electron. So that's number 1 electron, number 2 electron, number 3, number 4, number 5, number 6, and the number 7. Now oxygen is also having 7 electrons in its outermost shell. Now what's gonna happen? There will be the formation of bond between the carbon and the oxygen, 1 more bond, and that will be in between this electron and this electron. Now the octet is completed for carbon as well as oxygen. Let me recount it for you. I'm counting the electron. Sorry, I'm counting the electron for carbon first. The number 1, number 2, number 3, number 4, number 5, number 6, number 7, and the number 8. So the carbon got 8 electrons in its outermost shell now, after the formation of 3 bonds between carbon and the oxygen, in which the both electrons of third bond are contributed by oxygen atom. Now let's count the outer electrons for oxygen. That's number 1, number 2, number 3, number 4, number 5, number 6, number 7, and the number 8. So we got 8 electrons for oxygen also. Now, as oxygen has donated its 1 electron to carbon, due to which oxygen will carry a +1 charge, and carbon has gained 1 electron from oxygen, so carbon will will acquire a -1 charge. Now let's calculate the formal charge for carbon and the oxygen. Formal charge of carbon. How many valence electron does carbon have? 4. That's the standard thing. Minus the number of non-bonded electrons. The number of non-bonded electrons of carbon in this case are the number 1 and the number 2. So we got the 2 non-bonded electrons. Minus the number of bonds formed by carbon. The number of bonds formed by carbon are number 1, number 2, and the number 3. The carbon is forming 3 bonds, so it comes out to be 3. So 4 minus 2 minus 3 comes out to be -1. So it signifies that carbon is bearing -1 charge in case of carbon monoxide. Now let's calculate the formal charge of the oxygen. Formal charge of oxygen. Now, how many valence electrons does oxygen have? It's 6. Minus number of minus number of non-bonded electrons of oxygen. Just focus on the structure, the number first electron and the number second electron. So oxygen is having 2 non-bonded electrons. It's 6 minus 2. Minus the number of bonds formed by oxygen. The number 1, number 2, and the number 3. Oxygen is forming 3 bonds, so it's -3. So 6 minus 2 minus 3 comes out to be +1. That means oxygen is bearing +1 charge in case of carbon monoxide. Carbon is having -1 charge, oxygen is having +1 charge. So I'm using the formula that formal charge is equal to the number of valence electrons in an atom minus number of non-bonded electrons of that atom in a covalent compound or in combined state minus the number of bonds formed by that atom in a covalent compound. I hope you all understood these 3 examples very clearly. If any student have a doubt, please do leave a comment in the comment section. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.